Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. 12,900 years ago, there was a great extinction in North America. All animals weighing more than 100 pounds disappeared along with the Paleolithic Clovis culture. The extinction coincided with a period of global cooling that lasted 1,300 years, called the Younger Dryas cooling event. For many years, scientists thought that the sudden onset of glacial weather could have caused the extinction, but in 2007, a new publication by Richard Firestone and several co-authors proposed that the extinction event could have been caused by the impact of a comet, which also could have caused a global winter. The publication proposed that the extraterrestrial impact, or airburst, had occurred over the Great Lakes, and that mineral microspherules found at the Younger Dryas boundary were the result of the extraterrestrial explosion. The Younger Dryas Impact Hypothesis was appealing because one single event could account for the extinction and the cooling event, but the hypothesis was widely rejected by geologists, astronomers, and physicists because Firestone and his co-authors had not presented the expected evidence for extraterrestrial impacts, which includes minerals demonstrating shock metamorphism from the great pressure exerted by the hypervelocity impact. In 2009, Firestone proposed that Carolina Bays and the Nebraska rainwater basins formed from the shock wave of the comet explosion. The Carolina Bays and the Nebraska basins are shallow elliptical depressions oriented toward the Great Lakes. Opponents of the Younger Dryas Impact Hypothesis pointed out that the diverse dates of the terrain on which the bays are found meant that the bays had formed over a span of thousands of years, and thus they could not have formed from a single cataclysmic event. In 2013, Michael Petayev and several co-authors found a platinum anomaly at the Younger Dryas boundary when examining ice cores from the Greenland Ice Sheet Project 2. Platinum is not a common element in the Earth, but it is more common in extraterrestrial material. Many years earlier, iridium, another rare metal, had been used as a marker of the Cretaceous-Paleogene boundary, which implicated an extraterrestrial impact as the cause of the extinction of the dinosaurs. The platinum anomaly was the type of evidence needed to strengthen the plausibility of the Younger Dryas Impact Hypothesis. All that was needed now was to find a crater and proof of shock metamorphism. In contrast to the Younger Dryas Impact Hypothesis that proposed an extraterrestrial event and then tried to find supporting evidence, the Glacier Ice Impact Hypothesis, published in 2017, was derived from a geometrical analysis of the Carolina Bays and the Nebraska rainwater basins. The analysis found that the prototypical shape of these geological features is elliptical and that they can be modeled as mathematical conic sections. The Glacier Ice Impact Hypothesis proposed that the Carolina Bays were created by the secondary impacts of glacier ice chunks ejected by a meteorite impact on the Laurentide ice sheet. The impacts of the ejected ice chunks produced seismic vibrations that liquefied on consolidated ground, and the ice projectiles created inclined conical cavities that were remodeled into shallow elliptical bays by viscous relaxation. A supporting experimental model confirmed that many of the features of the Carolina Bays, such as the raised rims and overlapping bays, could be explained by the formation of conical impact cavities on a viscous surface and the subsequent reconstitution of the stratigraphy by viscous relaxation. The experiments also showed that impacts on viscous ground at ballistic speeds are plastic deformations that do not expose the subsurface to light, and thus the dates of the subsurface obtained by optically stimulated luminescence correspond to the dates of the terrain and not to the date of bay formation. The Glacier Ice Impact Hypothesis used the convergence point of the Carolina Bays and the Nebraska rainwater basins in Saginaw Bay, Michigan, as the site of the extraterrestrial impact. The convergence point had been calculated in 2010 by Michael Davies using great circle trajectories adjusted for the Coriolis effect. The Glacier Ice Impact Hypothesis established a mathematical foundation that can serve as a physics-based model for the Younger Dryas extraterrestrial impact. The ellipticity of the Carolina Bays is used to determine the angle of impact, which is also the approximate launch angle of the ice chunks from Saginaw Bay. Ballistic equations use the distance of the bays from the convergence point to calculate launch speeds, trajectory heights, and duration of flight. Yield laws correlating energy to crater size are used to calculate the mass and size of the ice projectiles. The sum of the energies of all the bays is used to calculate the energy and size of the extraterrestrial impact using the law of conservation of energy. The explanatory power of the mathematical model makes it possible to provide a minute-by-minute account of the Younger Dryas extinction event. The orbit of the Earth crosses the debris fields of various comets. This provides a predictable pattern of Leonid, Perseid, and many other meteor showers every year. There has been some speculation that during one of these crossings, a large piece of a comet hit the Earth, causing the Younger Dryas extinction. T-60 seconds. Atmospheric effects on a projectile. 60 seconds before the extraterrestrial impact, the comet or asteroid would have been entering the Earth's atmosphere. The atmosphere has a thickness of 100 kilometers, and a trajectory tangential to the Earth's surface would take a meteorite approximately 1,100 kilometers through the atmosphere. This distance would be traversed in 65 seconds by an asteroid with a speed of 17 kilometers per second. A comet with a speed of 50 kilometers per second would cover the same distance in 22 seconds. An approach from the northeast toward the impact point would have taken the extraterrestrial projectile over a portion of Canada covered by the Laurentide ice sheet. The ice sheet would have protected the Earth's surface from the searing radiant heat of the projectile, and there would not have been much burning. However, Firestone's 2007 paper and Wolbach's 2018 papers claimed that the passage of the meteorite through the atmosphere would have ignited forests and caused widespread burning. This means that the extraterrestrial projectile had to travel over forested land. This would have happened if the meteorite had approached from the southwest and entered the atmosphere at the Arkansas-Missouri border. The radiant energy of the incandescent projectile would have burned and blinded fauna and ignited fires along a broad swath under its 1,100 kilometer trajectory toward the impact point in Saginaw Bay. Within a few seconds, a thunderous shockwave would have knocked down trees and deafened fauna along a wide corridor under the path of the projectile. T-0, contact and compression. The contact and compression stage of an extraterrestrial impact lasts less than 1 second. The swiftly moving projectile pushes target material out of its path, compressing it and accelerating it to a high velocity. Most of the projectile's initial kinetic energy is transferred to the target in a volume not much larger than the projectile itself. Shock pressures developed during the early stages of the hypervelocity impact reach hundreds of gigapascals that far exceed the yield strength of both projectile and target. The great pressure from hyperspeed impacts creates planar deformation features in quartz crystals that distinguish impact craters from craters formed by terrestrial processes. Based on the convergence point of the Carolina Bays and Nebraska rainwater basins, the impact point is Saginaw Bay, and the crater may be Huron Lake, whose deepest point is perfectly aligned with Saginaw Bay. The law of conservation of energy allows us to use the energy required to form all the Carolina Bays to estimate the energy of the extraterrestrial impact, which corresponds to an asteroid with a diameter of 3 kilometers. An impact of this size would create a fireball with a radius of 30 kilometers that would ignite fires hundreds of kilometers from the impact site. The fireball would be followed by an air blast with hurricane-force winds that would blow down most trees and strip off the leaves of the ones that remain standing. Any animal or humans within 500 kilometers of the explosion would be killed or severely injured, but the worst phase of the extinction was yet to come. T+1 second. Crater excavation. The excavation phase of an asteroid with a diameter of 3 kilometers lasts approximately 30 seconds. During the excavation phase, a hemispherical shockwave propagates into the target. The decompression that follows the shockwave of the impact sets target material in motion and starts opening a crater and ejecting material ballistically. Some of the earliest and fastest ejecta consist of the vaporized projectile, which is dispersed in an expanding vapor plume. The last debris ejected from the extraterrestrial impact has the least energy and starts falling close around the crater. The formation of the vapor plume for an impact on ice requires a lot of energy because the ice has to undergo two-phase transitions, first into liquid water and then into steam. The vapor plume cools as it expands, and minerals vaporized from the projectile and target condense into microscopic spherules that are carried far and wide by the atmosphere. The platinum contained within the meteorite is vaporized and distributed in the same manner. The expanding vapor plume at the impact site accelerated the ice chunks ejected from the Laurentide ice sheet and sent them in ballistic trajectories with launch angles averaging 35 degrees and speeds of 3 to 4 kilometers per second. From the volume of the ice boulders that form the Carolina Bays, we can estimate that the extraterrestrial impact made the crater 45 kilometers wide on the ice sheet. The thick layer of ice dissipated much of the meteorite's energy and prevented the formation of a typical extraterrestrial impact crater on the land. The high-temperature vapor plume of the extraterrestrial blast in Michigan created a high-pressure shockwave that expanded around the impact area and disrupted the jet stream. This would have caused changes in the atmospheric circulation patterns that resulted in unusual weather events. T plus 30 seconds. Crater modification. The modification stage begins after the crater has been fully excavated. The bowl-shaped transient crater created during excavation collapses under gravity as loose debris slides down the interior walls of the crater. The crater from the impact on the Laurentide ice sheet was immediately filled by ice calving off the glacier and by water from the ice melting around the cavity. The impact site became a boiling cauldron, producing clouds of steam as the water quenched the incandescent ground. The hot water at the impact site found a path toward lower terrain and under the glacier. The water under the glacier created drumlins, which are streamlined mounds shaped by the flow of water. The meltwater also buoyed the glacier and lubricated its movement toward the sea. T plus 3 minutes. Seismic shock waves reached the East Coast. The Clovis people and the fauna in the East Coast would have seen the bright flash of the extraterrestrial impact in the northwest. The seismic shock waves from the cosmic collision, traveling at approximately 5 to 8 kilometers per second, reached the East Coast 3 to 5 minutes after the flash. By this time, the sky was ominously dark as the ejected glacier ice boulders approached in suborbital space trajectories. The ballistic equations tell us that the ice boulders reached heights of 150 to 370 kilometers above the surface of the Earth, well above the atmosphere. Water ejected above the atmosphere or carried by the ice boulders turned into ice crystals that also darkened the sky. These ice crystals went into low Earth orbit and blocked the light of the sun for hundreds of years until they turned into water vapor by sublimation. Some of the boulders collided in mid-flight and their trajectories were diverted. These deflected ice boulders would eventually produce heart-shaped bays when they hit the surface. T plus 6 minutes to T plus 9 minutes. Glacier ice bombardment. The saturation bombardment by the glacier ice chunks was the most lethal part of the extraterrestrial impact. The blast from the initial contact had a kill radius of 500 kilometers, whereas the secondary impacts of the ice boulders had a kill radius of 1,500 kilometers. The ice boulders re-entered the atmosphere at 11 times the speed of sound. The leading surfaces of the ice formed shock fronts of steam that left condensation trails in the atmosphere that further darkened the sky. A small base of 200 meters, approximately the length of 2 football fields, were made by ice projectiles with energies of 13 kilotons of TNT. This is about the energy of the bomb dropped on Hiroshima. Bases of 1 kilometer were made by ice projectiles the size of Yankee Stadium with energies of 3 megatons. The impacts were accompanied by deafening sonic booms. The seismic vibrations of impacts on unconsolidated ground close to the water table liquefied the ground and allowed the impacts to form inclined conical cavities, which became shallow elliptical bays by viscous relaxation. Ice boulders hitting hard ground shattered on impact, producing deadly high-velocity ice shards. All along the East Coast, from New Jersey to northern Florida, where the bays have been preserved, there is not a tract of land that is not completely covered with Carolina bays. This means that no matter where you stood or where you tried to take shelter, an ice boulder would hit you and kill you. The trembling ground and the quagmire created by liquefaction made futile any attempt at running. All living things within 1,500 kilometers of the extraterrestrial impact site were doomed. The areas without Carolina bays within this circle were also bombarded with the same violent intensity. But because the ground was hard, the ice boulders disintegrated explosively without forming conical cavities. The description of the Orleton Farms mastodon shows that it suffered a violent end that could have been the result of death by high-velocity ice shards. Unfortunately, the mastodon remains were not dated, and it cannot be said with certainty that the death occurred at the Younger Dryas boundary. The report says that the skeleton proved to be badly disturbed and the bones crushed and broken. As an example of the amount of disturbance, one of the ribs lay beneath one of the tusks, while another was thrust through an aperture in the pelvis. A shoulder blade rested to the right of the skull, and one of the large neck vertebrae was found about 10 feet from the skull, near a portion of the pelvis. In spite of the wide dislocation of the parts, the bones of one of the feet remained intact and in place, very possibly in the spot where the animal last stepped. T plus 10 minutes. Ice bombardment stops. By 10 minutes after the extraterrestrial impact on the Laurentide ice sheet, most of the ejected ice boulders had completed their trajectories with noisy landings, but the noise did not stop when the bombardment stopped. Sound traveled more slowly than the ice projectiles, and the sound of distant impacts continued to rumble like faraway thunder. The land was shrouded in darkness by the vapor trails and the ice crystals that blocked the light of the sun. The air was thick with moisture, dust, and smoke. After the saturation bombardment, the sandy soil close to the water table was covered with elliptical Carolina bays, and hard ground was covered by half a meter of ice from the ballistic hailstorm. T plus 2 hours. The extraterrestrial impact site had a lot of residual heat that started melting the surrounding glacier. As the meltwater started flowing, massive flooding washed away evidence of the extraterrestrial impact. The ice dust produced by the bombardment on hard surfaces drifted beyond the 1,500 kilometer impact zone and covered the vegetation. The ice dust smothered plant life and created moist conditions that promoted growth of algae that formed black mats. The soil layer with black mats marks the Younger Dryas boundary and occurs mostly beyond the 1,500 kilometer radius where the secondary glacier ice bombardment occurred. Vance Haynes attributes the black mats to relatively moist conditions as a result of higher water tables indicated by the presence of wet meadow soils, algal mats, and pond sediments. Some black mats do not have enough charcoal to indicate extensive biomass burning. T plus 24 hours and beyond. A day after the cataclysm, injured survivors, including the deaf, blind, wounded, or burned, continued to die. Animals that survived the ice bombardment, mostly small burrowing dwellers, started to dig out and emerged into a gloomy alien landscape where life would be much harder than before. Fauna outside the 1,500 kilometer boulder impact zone were also affected by the darkness and the colder weather. The devastated landscape was inhospitable for many hungry survivors. The ones that could not adapt eventually suffered a gradual extinction from the sudden ecological change. The destabilization of the Laurentide ice sheet triggered massive flooding that raised the level of the sea by more than 100 meters and disrupted the circulation of the ocean currents. The rising seawater flooded continental seashores and covered many islands populated by humans. This great flooding event may have contributed to the ancient stories of Atlantis and a biblical flood. How do we know all this? Many of the clues to the past are written in the Earth's physical structure. Geologists can interpret the distinctive signatures left by impacts, glaciers, water, and wind to reconstruct previous geological events. American physicist Richard Feynman said in 1964, "Mathematics is a tool for reasoning. By mathematics, it is possible to connect one statement to another." The scenario presented here is deduced from the geological record, the elliptical geometry of the Carolina Bays, and the convergence of the bays by the Great Lakes, which makes possible the use of a physics-based model to reconstruct the events that led to the extinction of the megafauna 12,900 years ago.
Hey, this is AZ Cool, bringing you the Younger Dryas Rap. I'm going to tell a story, a very sad story of the Younger Dryas. This happened long ago, 13,000 years ago. The Clovis people lived with other fauna, mastodons and camels, mammoths, lions, giant armadillos, and the saber-toothed tigers. Then came a comet, smashing everything. The impact was so large that it killed the Clovis people. Gone were the mastodons and camels. mammoths, lions, giant armadillos, and the saber-toothed tigers. That's the sad story of the Younger Dryas. The weather got so cold from the global winter. 1,200 years of global winter. That's what we call the Younger Dryas. The story of a comet that killed the megafauna. The story of a comet that killed the Clovis people. The Younger Dryas. The Younger Dryas. Yeah.
Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.